Ashok has graphically described how we see everything through a lens. We have to in ordinary life. But we can forget that it's a lens, and the lens through which the scientific world is seen has become a very restrictive one. There's a great crisis in the heart of science at the moment. Between science and a conflict between science as an open-minded method of inquiry, which is what most people think it is. Most people think science is unlike everything else in that it's open, free, you have a hypothesis, you test it, you argue it, science can move on in this kind of free way. That's a kind of ideal, and I actually share that ideal. But the reality is, unfortunately, rather different. And at the moment, all the sciences are constrained by a particular worldview, the materialist worldview, which since the late 19th century has become the dominant philosophy on which all science is based, and it's become a kind of prison for scientific thinking. This worldview is made up of 10 particular dogmas, and what I do in my book, Science Set Free, is to take these 10 dogmas, bring them out into the light, and examine them scientifically to see how well they hold up as science. When one does that, it turns out that in each case the whole field opens up, new experiments become possible, new inquiries become possible, and science can burst out of these narrow limits. And I think be set free. That's why the book's called Science Set Free. It's really setting science free from the science delusion. The book in England is called The Science Delusion. And the science delusion is the belief that science already understands the nature of reality in principle, leaving only the details to be filled in. So the 10 dogmas I'm going to summarize briefly. I'm not going to have time today to go through all 10 in detail. But what they are is, first, nature is mechanical, nature is machine-like. The dominant metaphor for understanding nature is the machine. And what that means is that everything in nature, animals and plants and machines, we ourselves are supposed to be machines. We're lumbering robots, in Richard Dawkins' vivid phrase. Our brains are nothing but genetically programmed computers. We're mechanical. And what's a machine? Why is it different from an organism? This is a result of a paradigm shift that took place in the 17th century, which is what made modern science modern science. It became modern science by rejecting the previous system of understanding, which was dominant throughout Europe in the Middle Ages, which was taught in all the universities, which was the idea that nature is an organism. In the Middle Ages, people thought the Earth is an organism, the whole universe is a living organism. The stars and planets are living organisms. Animals and plants are living organisms with souls. That's why animals are called animals, from the Latin word anima, meaning soul. And that humans were like animals and plants, and that the soul of the plant shapes the plant. The soul is the form of the body, according to Aristotle and St. Thomas Aquinas. The vegetative soul shapes the plant. Animals are also shaped by their souls as they grow. Animals, in addition, have the animal soul that gives them their animal nature, the senses, the behavior, the instincts. We have all those souls like plants and animals, but we also have the rational mind, the spirit, which is the conscious mind that deals with reason, language, and so forth. That was the medieval view. And what this revolution in 17th century science did, and why it was a revolution, it said that, no, these things are not all souled, animate beings. The Earth is a machine, it's like clockwork. Animals and plants are like machines. They don't have souls. They don't have their own purposes. They don't organize themselves. They're designed by an external mind. And that was a new kind of theology. God became a kind of external engineering, mathematical designer of the world, machinery and of animals and plants. And the human body became a machine. The only thing left that wasn't mechanical in the world was the human mind. And that was the only thing, and it was not material. According to Descartes, This mind was immaterial, not in space and time, and it shared its nature with angels and with God, but the whole of the rest of the world was unconscious matter, including the human body. That was the worldview that became the basis of modern science. It was revolutionary because it rejected what everyone believed before, that we lived in a living world made up of organisms. So that's the first and foremost dogma in science, and it's been the dominant spirit of science from that moment to this. And that's why people talk about biotechnology, genetic engineering, factory farming. Animals are just machines, so they're just cogs in the production process. So that's the first dogma, nature is mechanical. The second dogma is matter is unconscious. The entire universe is made up of unconscious matter, the stars, the planets, animals and plants, even our bodies, except for our minds, which mysteriously are conscious in an otherwise unconscious universe. The third dogma is the laws of nature are fixed. The laws that govern nature, the mathematical laws, were all there at the moment of the Big Bang. They've been the same ever since, and they'll be the same forever. The fourth dogma is that the total amount of matter and energy is always the same. This is the principle of conservation of matter and energy. The fifth dogma, nature is purposeless. Nature is a machine. Machines have no purposes of their own. They only have the purposes that something outside the machinery gives them. In the case of a car, for example, it will go wherever you want it to go as long as it's in functioning order. It doesn't have a purpose of its own. Where it differs from an organism is that organisms do have their own purposes. If you get in a car, it will go where you want it to go. If you get on a horse, it might not. I've had this experience myself. I was horse riding in Ireland, and I found myself arriving at a stable rather than heading out over some beautiful mountains. So nature's purposeless, there are no purposes in life, in animals and plants, and the whole of evolution has no purpose or direction. It's just a matter of blind chance. That's dogma 5. Dogma 6 is that biological inheritance is material. Everything you inherit biologically is material. It's genetic in the DNA, or it's epigenetic, a modification of the DNA, or it's cytoplasmic inheritance. So inheritance is material. In a materialist worldview, everything's material. Dogma 7 is that your memories are material. Everything you remember is stored as traces inside your brain, memory traces, modified nerve endings, phosphorylated proteins, or whatever. People have looked for memories in brains for a very long time. They've actually failed over and over again finding them, but nevertheless everyone believes they must be there. Where else could they be? So this is the unquestioned dogma of the neurosciences, that memory is inside the brain. Dogma 8 is that the mind is inside the head. Your mind is nothing but the activity of your brain, so all your mental life is confined to the inside of your head. Dogma 9 follows from Dogma 8, and it's that psychic phenomena like telepathy are illusory. If all your mental activity is confined to the inside of your head, then your thoughts and intentions can't possibly have mysterious effects at a distance. So all the evidence for things like telepathy must be illusory. It's just coincidence, and if there's any seeming scientific evidence, then you know in advance it must be flawed or fraudulent, because it's impossible. And Dogma 10 is that mechanistic medicine is the only kind that really works. Alternative and complementary therapies may appear to work, but that's just because people would have got better anyway, or it's all the placebo effect. The only kind that really works is mechanistic medicine, because that's based on physics and chemistry. The body is a physical and chemical machine, so it can only be treated by physical or chemical methods, surgery or drugs. And all these other therapies are basically bogus. Well, those are the 10 dogmas that constitute the default worldview of educated people all over the world. We've exported this worldview to China and India and Africa and South America, and all educated people at least pretend to believe it in public, even if they don't really, because This is the worldview that smart people believe, and if you don't believe it, it proves you're superstitious, backward, uneducated, stupid. So no one wants to be thought those things. So this is the default position. It's the default position that dominates government, corporations, educational system, and it's just taken for granted within scientific institutions. Yet, I think it's become extremely limiting. All of these assumptions were at one time liberating, but they've hardened into these dogmas, and they imprison scientific thought. And what I do in my book is turn these dogmas into questions and examine them scientifically. Is nature mechanical? Is matter unconscious? Is nature purposeless? When you turn them into questions and look at them scientifically, then it looks very different. I'm not going to be able to deal with all of them today, I'm just going to deal with a few, but I'll start with matter and energy, because this is the dogma that I myself questioned least and last. I questioned many of the others throughout my scientific career, but this one was the one I considered the most firmly established and unquestionable of them all. It's only 2 or 3 years ago I began to question it. When I was writing this book, I realized that I had to deal with all 10 dogmas, and I couldn't leave this out. And I rather hoped that this one would turn out to be true, because I thought it might seem a bit biased if I said that all 10 dogmas were flawed, fundamentally flawed. And I quite like the idea of this one turning out to be true. It turns out to be one of the weakest of them all. First of all, we have to look at the history of these ideas. How did they come to be accepted within science in the way they are? Well, the idea that the total amount of matter and energy is always the same is something that starts from philosophy and theology, not from science. It didn't become a scientific belief because it had been proved by experiments accurate to many places of decimals. It started off in philosophy, and it started off, moreover, in the philosophy of ancient Greece. The ancient Greeks were preoccupied with the idea that reality was eternal. The ultimate reality was changeless or eternal. They probably got this idea from mystical experiences. Many mystics report that there's a realm of time, beyond time and space, that includes all other things. This actually is what Ashok was talking about, is that realm that's not in his lower bracketed realm, that higher realm, and it's not really in space and time in the normal sense. Now, the Greek philosophers did what he explained rather well, I thought. They took this experience of a timeless realm and tried to turn it into a theory. They put it in that square bracket box. And they came up with different ways of explaining eternal reality. Pythagoras and his school said that the ultimate eternal reality was mathematical, that the ultimate truth beyond space and time was maths, the numbers, proportions, ratios, and so forth. And that doesn't change. The world we live in does change, but the ultimate timeless basis is mathematical. Plato generalized the theory of Pythagoras and said, yes, the ultimate reality is outside space and time, but there are many different, it's not just maths, there are forms or archetypes of everything in nature, the Platonic forms or ideas. Every horse is a reflection of an eternal horse archetype or idea. Every hedgehog is a reflection of an eternal hedgehog idea. There's eternal realities outside space and time, and everything reflects them within time and space. They don't change, but this world does. That world's more real than this world. But the materialist school of philosophy, led by Democritus and Epicurus, these were great Greek philosophers too, they took a different view. They said reality, ultimate eternal reality, is matter. And matter is made of lots of little bits called atoms, which can't be split up by definition. And they undergo permutations and movements and recombinations and underlie the changing world we live in. It's made up of a permanent substratum, a permanent basis of matter. And matter is the only reality, matter in motion. So that was their answer. And materialism was revived in the 17th century along with mechanistic science. The founders of modern science were all Christians and sincere believing Christians, And they thought that the world machine had been made by God in the first place as a machine. He was an engineer, he designed it, he made it, he put it together, and he made matter in the form of atoms, which couldn't be broken up. They revived Greek atomism, but their atoms were God-given in the first place. And he also set the world machine in motion to start with and gave it a certain amount of movement, which continued forever because it was God-given. And that's why you have the total amount of matter remains the same, the atoms can't be destroyed, and the total amount of movement or energy remains the same because it's God-given. That's the basis of the law of conservation of matter and energy. Not accurate measurements with chemical balances and so forth. These principles were codified in the 19th century, in the 1850s, into the first law of thermodynamics, which is the law of conservation of energy. And the principle of conservation of matter and energy became a fundamental part of 19th century physics. Its roots were in the 17th century assumptions, and the roots of that go right back to Greece. This principle of conservation of matter and energy is useful as a kind of an accountancy principle for studying what's going on in nature. You get the balance sheet. It enables you to make equations. The total amount of matter and energy before a change equals the total amount after. It's useful, and it's a pretty good guide to many ordinary changes in nature. But is it an ultimate truth? Well, physicists themselves are less impressed by the laws of physics than the rest of us, and they haven't felt the need to stick to it very rigorously. In the 1980s, it became clear that galaxies were attracting each other far too much. That if you add up all the matter in a galaxy, all the stars, the gas clouds, black holes, make a generous allowance for planets that we can't see from so far away, add up all the matter in the galaxy, and then you work out, is there enough to explain the way they're attracting each other, as observed by astronomers? It turns out there isn't. They ought not to be attracting each other so much. Moreover, the stars within the galaxies are moving around the galactic center much too fast to be explained by the amount of matter that ought to be in the galaxies according to adding up what we know. So here's a crisis. The facts of astronomy simply don't fit the theory. So there's two options. Either the theory is wrong, or there must be a lot more matter than people had previously thought. So the simplest option is to say, well, there must be more matter. So physicists hypothesized or invented a large amount of extra matter called dark matter because you can't see it or detect it in any other way, to explain these facts. Well, how much dark matter is there? Simple. Just find out how much the galaxies are attracting each other. How much dark matter do you need to add in to explain the facts? That's how much there is. And if there's a galaxy that has an unusual bulge that you can't explain by the matter, well, there must be a dark matter cloud there that's causing it. So you can explain everything perfectly with dark matter. And that's what they did. And if you find new observations, then you just add in more dark matter or subtract it. And it turns out there's about, using these methods, about 5 times more dark matter than regular matter in the universe. What is it? Nobody knows, because by definition it's dark, its nature is literally obscure, and you can't detect it by any other means. People have tried and failed to detect it. There's no independent evidence for its existence, and yet it's a fundamental part of modern physics. However, once they'd added in all this extra dark matter, it created a new problem. The universe, as you know, is expanding as a result of the Big Bang. If you suddenly say there's 5 times more matter in the universe, that means the tendency for the universe to be pulled together again by gravitation is much greater. So the universe ought to have been slowing down. The expansion ought to slow because of all this matter until it stopped, and then everything was supposed to contract again until the whole universe ended in the opposite of the Big Bang, called in the trade the Big Crunch. This is the cosmology that was the predominant one in the 1990s. And people expected to find that the universal expansion was slowing down. When astronomers looked at the limits of the universe, at quasars and at galaxies, the most distant objects we can see, they found that far from slowing down, the expansion of the universe was speeding up, the exact opposite of what had been expected and predicted. So how do you explain that? Well, that means there must be something pushing it apart that no one had known about before, and that's dark energy. So, dark energy is a key part of cosmology. It's pushing the universe apart. How much is there? Well, how fast is it moving? Just a little amount of time to explain that. The equations of dark energy suggest that as the universe expands, you need more dark energies coming into being. The universe is a perpetual motion machine that increases the amount of energy. Some physicists argue that the amount of energy, that the new energy is offset by changes in pressure, so it's not really too worrying that there's more and more of this dark energy. But as things stand today, the estimates are that dark matter and dark energy make up 96% of reality. The regular matter and energy you learned about at high school makes up only 4% of reality. Now, are dark matter and dark energy conserved? Is the total amount always the same? Can they be converted to regular matter and regular energy? Nobody knows, because we don't know what they are, or what their properties are. And the total amount that physicists recognize changes all the time. I mean, 30 or 40 years ago, no one had ever heard of them. Suddenly, there's all this extra matter and energy in the universe, invented with the stroke of a pen by physicists. It could be abolished again if they changed their equations. So, are we in a certain world where rigidly defined amounts of matter and energy? Apparently not. Within quantum theory, there's another mysterious kind of energy called the quantum vacuum field, or the zero-point field. This is an essential part of modern quantum theory. And what it tells us is that in quantum theory, whenever matter and light interact, they do so, or whenever electric and magnetic phenomena occur, they do so through virtual photons or virtual particles that emerge from the zero-point field and then disappear back into it. The zero-point field, or the quantum vacuum field, is not a vacuum, it's a plenum. The world is full of energy. The world we live in is like ripples on an ocean of energy, a deep ocean of energy. There's more than enough of this vacuum energy in a teaspoon to power the United States for decades. There's huge amounts of energy in space, according to this theory. This raises the question, could we tap it? If we could, it would completely transform the world economy. There are people who think they can tap it, and who think they are tapping it. Out there are lots of people, dozens of people, who've made what are called above-unity devices, machines that produce more energy than you put into them. Now, as soon as somebody makes a claim like that, instead of everyone saying, wow, this is great, it has huge potential applications, they get a very different reaction. They say, this guy's a complete crank, this is a perpetual motion machine. And those around the world, they're totally taboo because they violate the law of conservation of matter and energy. So the people who have these inventions, far from being welcomed and retained as heroes, are driven into the outer darkness of fringe science. You can read about these things on the internet. If you put in a search on Google for above-unity devices or free energy machines, you'll find dozens of claims. Some of them may be cranks, some of them may be frauds. I know that some of them are genuine and sincere. I know one of these small companies in Britain, a friend of mine runs it, or helps run it. And I've seen their device, it seems to me genuine. These people are not frauds, they seem to be getting out about twice as much energy as they put in. They don't know how it works. A quantum physicist, Brian Josephson, who had a Nobel Prize for quantum physics, has been very impressed by it. He thinks it's genuine. But even with the backing of a Nobel laureate in quantum physics, they can't get serious investment, not because of a conspiracy by oil companies or anything like that, but when they do approach larger companies, the larger companies, they usually find someone who's interested to start with. Then they call up their physics advisor, who's a professor of physics at a leading university, And they call them up, say, we've got these people here who have this device that produces more energy than you put in. Say, forget it. You know, these are obvious cranks. You'll make fools of yourselves. You'll lose your money. Don't pay any attention. It's another perpetual motion machine. That's the state of play today. Now, how can we move things on? Well, my suggestion would be this. If I had a lot of money, I'd set up a prize for the best above unity device, $1 million prize, and ask people with these devices to come forward and have them tested by qualified engineers and physicists. And the purpose of the test would not be to try and debunk them or ridicule them or sneer at them, but to find out if they really work. No one has ever done that. This is simply not on the agenda of regular science. So you have a competition, you have a prize. If one of them did work, they'd win the prize. If several of them worked, the one that worked best would win the prize. And I think that would move things on, because investors would begin to get interested, governments would get interested. It would move this on from the present stalemate of all these people being relegated to the outer darkness. If nobody won the prize, that would be also a very interesting result. Defenders of conventional science would then have the pleasure of saying, I told you so. We would actually, for the first time, they'd have some evidence in favour of their belief. I would say not only should there be a prize, if I were a bookmaker, I'd open a book on this, and you have people betting, and ask conventional scientists to put their money where their mouth is, and bet that they want to win the prize, and see how much they're prepared to bet on it. If they're really confident, they'd bet millions. I suspect that really put to the crunch, most of them wouldn't bet more than about $20. But it would engage people, it would be fun, we'd find out something new, it wouldn't do any harm. I'm sure there are people out there who could afford to put forward this prize money. It would provide a public spectacle, it would create entertainment, the finals could be live on TV and the awards ceremony. It would move science on, and it might even transform the world economy. We wouldn't any longer need fracking, shale gas, tar sands, if we had another source of energy. This is not happening because of these taboos. It's the only reason I can think of for it not happening. Sometimes people say it's conspiracies. I don't think it is. I just think it's this blockage, a mental blockage.
It is.
Okay, well, let me say something about the next, another of these taboos, the idea that the laws of nature and the constants of nature are fixed. This is, again, a belief that goes back to ancient Greece. It goes back to Plato and Pythagoras. The founding fathers of modern science in the 17th century, Galileo, Copernicus, in the 16th century, Kepler, Descartes, Newton, were all Pythagoreans or Platonists. They thought that God was a mathematician whose mind contained eternal mathematics, and the laws of nature were mathematical ideas in the mind of God. Because they were in the mind of God, because they saw God in a kind of Platonic theological sense. There's a Platonic strand of Christian theology going back to St. Augustine. They thought this was a perfectly tenable Christian belief, and that the laws of nature must be fixed. The God of the Old Testament and the New Testament is not a God of eternal laws. He's an interactive God who evolves and changes along with the universe. But this Platonic God, that strand of Christian theology, led to the idea of eternal laws of nature. God created the universe and gave it eternal matter and energy and eternal laws. And that was the basis for this belief in eternal laws. And science acquired a huge prestige, especially in the 17th century, and then got even bigger in the 18th century, because people thought that scientists like Newton were finding out the eternal laws in the mind of God. That science was closer to God than religion, because it was actually understanding the inner workings of God's mind. That's how it acquired such high prestige, and how scientists became a kind of new priesthood, a position they still occupy today, more than ever before. So this was fine. In the 19th century, most scientists thought the universe itself was eternal. They got rid of the idea of a creator by saying the universe is eternal, eternal matter and energy governed by eternal laws. Everything went on fine until 1966, when the Big Bang theory became orthodox within physics. This theory tells us the universe began very small and very hot about 14 billion years ago. It was less than the size of a head of a pin, and enormously hot, and it's been growing, expanding, and cooling ever since, and new forms and structures have appeared within it: atoms, molecules, stars, galaxies, life, at least on this planet. And so it's an evolutionary universe, radically evolutionary. Now what about the eternal laws of nature? If they're truly eternal, they would have had to exist in a free-floating way before the universe, which is not eternal. Or, if they came into being with the universe, all of them would have had to appear suddenly about 14 billion years ago at the moment of the Big Bang, like a kind of cosmic Napoleonic code, and just coming into being all at once. And that's what scientists assume. But there's no evidence for it whatever. This way of thinking is a hangover from an older way of thinking that goes back to ancient Greece, not something established by careful evidence and accurate observations to many points and places of decimals. As my friend Terence McKenna used to say, modern science is based on the principle of give us one free miracle and we'll explain the rest. And the one free miracle is the appearance of all the matter and energy in the universe and all the laws that govern it from nothing in a single instant. So, if we question the idea of laws of nature in an evolutionary universe, why shouldn't the laws evolve? Everything else does. Why not? And as soon as you begin to think about it, you see that the very concept of law of nature is anthropomorphic. Only humans have laws, and what's more, only civilized humans. Tribes have customs. So this extrapolates a human concept onto the whole of nature. And again, in the rather naive theology of the 17th century, that was okay. God was the lawgiver, like a cosmic emperor, and he made sure that everything obeyed the laws of nature because he was all-powerful and acted like a cosmic law enforcement agency. As C.S. Lewis once said, to say a stone falls to earth because it's obeying a law makes it a man and even a citizen. So the concept of law is very anthropomorphic and not really appropriate. But if we stick with that metaphor, we see that actually human laws do evolve. They're not fixed forever. So if we really take the metaphor seriously, we'd have evolving laws. But I think it's better to shift to a less anthropocentric metaphor, and the one I like is habit. As long ago as the beginning of the 20th century, the great American philosopher C.S. Peirce proposed that in a universe that evolves, the regularities of nature would evolve too, and he suggested we should think of them as habits, not laws. Several other philosophers thought the same. William James was one of them. I myself think that's much the best way to think about it, and I think we live in a universe of evolving habits. My own particular theory of evolving habits is called morphic resonance, and I think that similar things influence subsequent similar things across space and time by a kind of resonance across time and space. What this means is that each kind of thing in nature has a collective memory, and every individual draws on it and contributes to it. This applies to crystals and molecules as well as living organisms. The theory says that if you make a new kind of chemical and crystallize it for the first time, it'll take a long time to crystallize, a new habit has to come into being. There is no pre-existing habit of this crystal form of the lattice structure. The second time you make it, anywhere in the world, it should happen a bit easier because there'll be a resonance from the first time. The third time, a resonance from the first and the second times. The fourth time from the first, second, and third times. So there'll be a cumulative build-up of habit through morphic resonance, and the crystal should get easier to crystallize all over the world as time goes on. That's exactly what chemists find. Now, the same should apply to animal behavior. The theory predicts, surprisingly, that if you train rats to learn a new trick in Harvard, then rats all over the world should learn the same trick quicker because the rats have learned it in Harvard through morphic resonance. Rats in Melbourne, Australia and in Edinburgh, Scotland should learn it quicker. Well, in a very long series of experiments, one of the longest in the history of rat psychology, which dominated psychology departments in the Western world through most of the 20th century. And in one of the longest series of experiments, exactly that happened. Rats trained at Harvard got about 10 times better at escaping from a water maze. Over 20 or 30, 25 generations, there was an improvement. They got better and better and better, big improvement. When this was repeated in Melbourne, Australia, and Edinburgh, Scotland, they started where the Harvard rats left off. And they continued to improve. And it wasn't a genetic effect or an inheritance of acquired characters, because all the rats of that breed improved, not just ones whose parents had been trained. This really strange and surprising result was simply left lying around in the scientific literature because no one could explain it. A similar effect is occurring with humans. People are getting better at acquiring new skills, windsurfing, skateboarding, computer programming, and so on. And one of the best lines of evidence from humans comes from IQ tests. IQ tests have been done in much the same way for the last 80 years. And I predicted in the 1980s that people should be getting better at IQ tests, not because they're getting smarter, but because so many people have done the tests already. Their tests should be getting easier. And exactly that is now known to happen. There's been a more than 30% improvement in average IQ test scores over the 20th century. There's no independent evidence people are getting smarter. They're just getting better at doing these tests. We have a similar situation in schools with exams. We're always reading controversies about dumbing down of exams because grades keep going up in many exams. And then there's a big controversy in Britain. People's grades in exams are going up. And then some people say that's because the schools are all dumbing them down, and the government's dumbing them down because they want to make it look as if the educational system's getting better. And the government says the education system is getting better. You know, it's a success of government policy. But it could just be a morphic resonance effect. So I think that the idea that laws of nature are fixed can be replaced by the idea of evolving habits of nature. It makes much more sense of the phenomena and is much more consistent. I discuss this in my book Science Set Free, but in more detail in my books A New Science of Life and The Presence of the Past. So if you're interested in the details, you can find more there. Another dogma that I'll turn to now is the idea that matter is unconscious. This is not something that scientists have proved. It's not even something they've discussed. It's something they just assumed. And they've assumed it since the 17th century. They assumed it because Descartes said so. Now, Descartes was, as Ashok said to us earlier, a profound philosopher. His idea of the I am aspect is a really impressive aspect of his philosophy. But he then created a split in his philosophy. He said that the whole of nature is machine-like, mechanical and unconscious, and the mind, the human mind and the minds of angels and God, are totally separate. They're not in nature, they're outside nature, they're not in space and time, and they're not material. And he created what's called Cartesian dualism. He created a split between mind and body, spirit and matter, humans and other animals, because humans have this immaterial mind, but animals didn't, so they're just machines and they can be treated as we like in factory farms or in vivisection laboratories. And a split between nature and God, because only human minds, angels and God were immaterial. The rest of nature was made up of unconscious, material matter. So matter was defined as unconscious because consciousness was split off from it in this dualistic system of philosophy. So when scientists today say matter's unconscious, they've never proved it. They've just believed it in this way Descartes said so and created this rather split view of nature in the 17th century. Now, Cartesian dualism creates the idea of two radically different things, and many people don't like the idea of two radically different things constituting reality, especially since no one knows how they can possibly interact. I myself don't like it, but there's two ways you can go from, well, there's three ways you can go. One is to say, well, two is too many, we'll reduce it to just one, And that's been the dominant strand in Western philosophy since the 17th century. The other way is to say 2 is too few, and we need at least 3 interacting principles, a kind of Trinitarian principle at the basis of things. That's the way I myself prefer. But the dominant attempt has been to reduce dualism to monism, to go from 2 to 1. One school of thought, as Professor Gangadine said, is the idealism, which says everything is spirit. Everything is spirit. Matter's just kind of dumbed down mind, but mind is the one ultimate fundamental principle. But the more popular route is to say everything is matter, that spirit or consciousness is nothing but matter. And that's materialism. That's exactly what materialism is. It collapses Cartesian dualism into a monism that says matter's the only reality. It's not 2 things, matter and spirit, or matter and mind. It's just one thing, matter. And that's the dominant philosophy of science since the late 19th century. It took over science, and ever since then, the sciences have been a wholly owned subsidiary of the materialist worldview. Now, the problem with this is immediate and obvious, that if the whole of matter is unconscious, and we're made of matter, then how come we're conscious? We ought not to be. We ought to be machines, unconscious machines, and yet we're not. So how do you deal with that? Well, the way materialists usually deal with it is by saying, we're not conscious. We are machines. Consciousness is an illusion. It doesn't really exist. The dominant school of psychology in the Western world, particularly America, in the 19th century, in the 20th century, was behaviorism, a school of psychology that denies consciousness, that says it is of no scientific interest or importance. The role of psychology is to study muscular movements and glandular secretions, things that can be measured objectively and are part of science. And that we won't deal, as B.F. Skinner said, with illusory concepts like consciousness. Philosophers of mind, most of them in the English-speaking world are materialists, have tried in many ways to get rid of consciousness from philosophy and science. And either by saying it doesn't exist, that's called eliminated materialism. They say that people talk about subjective states, but that's just what they derisively call folk psychology. And as when people know enough about neuroscience, we can just explain everything in terms of the functioning of the brain. Get rid of all this subjective nonsense that is meaningless language. That's one approach. Another is the epiphenomenal school. They say that consciousness is nothing but an epiphenomenon of the physical activity of the brain. It doesn't do anything. It's not a cause. It's just an effect of brain activity, like a shadow. It doesn't do anything. The third school is to say consciousness is an illusion that's produced by the brain, but again, it doesn't do anything. The problem is the attempts to dismiss it as illusory don't explain consciousness, they presuppose it, because illusion is a mode of consciousness. So these materialist theories of mind, attempting to dismiss consciousness, have gone round and round in circles. This is one of the principal games and forms of employment for philosophers in the English-speaking world. And they can go on with this indefinitely. What they do is point out the flaws in somebody else's materialist theory, and they put their own. The others then point out the flaws in theirs, and they move on, and so on. They chase their tails, and they've been doing that for decades. Most of the philosophers in the English-speaking world belong to those schools. A few of them have broken loose. One, Galen Strawson, who's a British philosopher living in America, has come to the conclusion that philosophy just has to move on. And the only way he can see it moving on is to say that there must be a potential for mind or consciousness in all matter. In other words, it's a kind of animism again, saying there must be a mental aspect to all matter, even electrons. I'm reading at the moment a book that's just come out by Thomas Nagel, one of America's leading philosophers. It's called Mind and Cosmos, and the subtitle is Why the Materialist Neo-Darwinian Worldview is Almost Certainly False. And Nagel has broken ranks too. It's a very good book. It's clearly argued. He says that the materialist worldview is ripe for replacement. It simply can't work as philosophy or as science. And yet Nagel says, we need something else, but I don't know what it is. And I think that actually we can go further than Nagel. I think the outlines of the alternative are already present. They're already with us. But Strawson and Nagel are two philosophers who break it loose, and they say we have to see that there's some kind of mentality in all nature. Now, the 20th century philosopher who took that view furthest was Alfred North Whitehead, one of the greatest philosophers of the last century. And Whitehead argued that even electrons and atoms must have some kind of mentality or mental life. That he was a panpsychist, the idea there's a psyche or mind or mental aspect to all material, self-organizing material things. He was very influenced by quantum theory, the first philosopher to take it seriously and to see its implications. Quantum theory tells us that electrons and atoms are not solid objects that just persist. They're waves of energy, they're wave-like. Because they're wave-like, they take time. A wave can't exist at an instant, at a single point or a single time. Think of a wave on the sea. You can't have an instantaneous wave. A wave is spread out in time and in space. It has to have time to go through a wavelength of activity, and to have even its minimum identity has to be at least one wavelength. It's usually several before you can characterize it as a wave with a wavelength. That means it takes time. That means that everything in nature, even the most simple material systems like electrons, are not objects, they're processes. They're processes and they have time within them. Because they have time within them, they have a future and a past within them, a future pole and a past pole. And where Whitehead was most interesting in his philosophy was in his interpretation of the relation of mind and body. Most people think of this relationship in terms of spatial metaphors, inner and outer, the inner life, the outer world. It's a spatial metaphor. But Whitehead said the real relation of mind and body is in time. The mental pole is the future pole, the physical pole is the past pole. Now, the future pole is concerned with possibilities, and in quantum theory, the Schrödinger wave equation, which is how you describe things in quantum theory, is an equation that gives you a view of all the possible things an electron can do. The equation for this electron tells you all the things it could do in the future. It's a realm of possibility. When the electron interacts with something, a measuring apparatus, for example, or with another chemical, then these possibilities collapse down to one thing. As soon as that's happened, it's an observable objective fact that is in the past. And now a new wave of possibilities opens up. All these new possibilities. As soon as that something happens, it again collapses down, it's in the past. So it's possibility in the future and fact in the past. And our minds are like that too. Our minds are concerned with possibilities. Most of our mental activity, our conscious mental activity, is working out what we're going to do next. You know, what should I do next? All of us at one stage had to decide that we were coming here today. We wouldn't be here otherwise. And we all had lots of other things we could have done this afternoon. But at some stage we chose, out of those many possibilities, to come here. We made that choice about a potential future that hadn't yet happened. And then having made the choice, we actualized it through coming here and sitting down or standing up. And we're here, and in fact we're here. That choice has turned into an observable fact. We can be photographed, measured, weighed, etc. It's a fact, we're here. It's already in the past. And when we made that decision, it was in the future. And our mental lives, one's our conscious mental lives, not our unconscious mental lives, which are largely habitual. Our conscious mental lives are about coexisting possibilities and choosing among them. Now, that they exist in the virtual future. And I think Whitehead's point about this relation of future to past is a very interesting one, and it suggests that mental causation, the causation of our minds interacting with our bodies, is in a flow from virtual futures towards the past, whereas physical causation, ordinary regular physical causation, is a kind of pushing from the past. It's a flow from the past towards the future. And they overlap in the present. And I think that is the best way I've come across of thinking about the interaction of mind and body. Now, this means that if we think about a mental pole to the life of electrons, and atoms and self-organizing systems like crystals and plants and animals and people and societies like flocks of birds. All these things are self-organizing, all have some kind of mental pole. But we can go further. We can say, well, what about really big things that are self-organizing? The sun, the galaxy. What about their mental pole? Does the sun have a mental life? Well, why not? I think the sun thinks. And I think the galaxy as a whole may have a kind of mind, intentions and purposes. Now, that's a shocking thought, as you all realize. We're not meant to think about it. We're not meant to bring up the idea that the sun thinks. That's childish and primitive. It's what Hindus think, it's what the Greeks think, it's what traditional people think, and it's what children think, which is why they draw the sun with a smiley face. It's animistic, it's primitive, it's superstitious, and we're grown-up people who've grown out of that. We know the sun's nothing but an unconscious hydrogen bomb that emits light in accordance with the laws of physics. But do we really? It's not that we've thought about it long and hard, it's that we've been told we can't think about it because of this taboo created by this dogma. And scientists take it for granted the sun is unconscious, but is it because they thought about it? No, it's because they haven't thought about it. They're not allowed to think about it, it's taboo, or if they do, they wouldn't tell their colleagues. Now, I helped organize a symposium some years ago over the summer solstice in England to discuss, is the sun conscious? We had a Hindu philosopher, we had mythologists, we had a cosmologist, a physicist, a psychologist. It was a fascinating meeting. And of course, we all agreed we couldn't prove that the sun was conscious. And of course, I can't prove the sun's conscious, but you can't prove it's not. It's a truly open question, as soon as you move beyond this taboo. But we discussed, if the sun is conscious, what does it think about? And what level of consciousness might it have? Might it be a low level like a plant? Might it be a high level like a person? Or vastly higher than any person? We couldn't decide that either, but then we did think, well, if it thinks about, what would it think about? Well, one thing it would think about is its body, the solar system, which is the body of the sun, which includes all the planets and the movements and all the electromagnetic radiation, all the electromagnetic fields. We're within them now. We're within the field of the solar system. All the electromagnetic activity inside your brain is within the field of the solar system. So it would think about what's going on within its body. It would also think, no doubt, about its peer group, the other stars within the galaxy. And they may be interacting in ways that we've scarcely begun to imagine. Then the mind of the whole galaxy might include all those stars, and then groups of galaxies may have minds, and the whole cosmos may have a mind. This is, of course, an old idea. Plotinus and the Platonic school in the ancient world talked about the anima mundi, the soul of the world, which would be like the soul of the entire universe. These are possibilities. There's nothing in science that rules out these discussions except the taboo. So, is matter unconscious? It's just an assumption. There's nothing in science that's proved it. As soon as you think about it, all sorts of new possibilities begin to open up. Now, finally, I haven't time to deal with more than one more delusion of science, and I'll take the idea that the mind is in the brain, that your mind is confined to the inside of your head. This is a fixed assumption in science, and it has to be inside your brain because your mind is nothing but mental activity. The mental activity is nothing but the activity of your brain. I've dealt with the background to this, that's what it is. For 99.9% of neuroscience, that's what it is. And that's why when people want to investigate consciousness in the modern world, they get huge grants from the National Science Foundation and that kind of thing to set up brain scanners and do fMRI scans, meditating Tibetan monks. That's the God spot in the brain. That's where it all is. Everything's got to be in the brain. Well, the brain's part of it, for sure. I'm certainly not denying that, but is it all there is to it? Is your mind nothing but the activity of your brain? I don't think it is. I think our minds are much more extensive than our brains. I think our minds work through fields, which I call morphic fields. and they extend out far beyond our brains. We're used to the idea of fields that extend beyond material systems. The field of a magnet is inside the magnet and extends beyond it. The field of the Earth, the gravitational field of the Earth, is inside the Earth and extends invisibly far beyond it. It holds the moon in its orbit. The field of your cell phone is inside the cell phone and extends invisibly beyond it. It wouldn't work otherwise. And I think the fields of our minds are inside our brains but extend invisibly beyond them all the time. I think that's what's happening right now. As you see me standing here, I think your mind's extending beyond your brain. The easiest way to think of this is, in fact, in terms of vision. What happens when you see something? As you see me now, you all know the standard story. Light's reflected from me, goes through the electromagnetic field, enters your eyes, inverted images on your retinas, changes in the cone cells, impulses up the optic nerves, and changes in various regions of the brain, which can be revealed through fMRI scanners or other scanning devices. Well, so far so good. The trouble is, all this does is describe what happens in the brain. It doesn't explain vision. The first point about it is you're conscious of what you see, and there's no explanation for that at all, as I just said. The very existence of consciousness is called by philosophers of mind the hard problem, because nobody knows how to solve it, as I've discussed. But the second point is much less realized, and you may not have thought about it before, which is where are the images you're seeing located? Where is your image of me? Is it inside your brain, or is it where it seems to be? Now, the official scientific answer is that it's inside your brain. All your subjective experience is inside your head. It's nothing but mental activity, brain activity. Inside your head is a three-dimensional, coloured world representing everything you're seeing outside your head. There's a little Rupert somewhere inside your brain. If you look at the sky, then the sky you're seeing is inside your brain. And that means your skull must be beyond the sky. That's the official worldview of conventional science. It's not usually spelled out or taken to its logical extreme, but that's what it says. No one's ever seen a virtual reality display inside a head, and yet it's taken for granted that the brain mysteriously generates these virtual reality displays inside the head. But there's an alternative that is simply not considered within science, because it's what young children believe, it's what primitive people believe, it's what Hindus and Buddhists believe, and it's what the ancient Greeks believed, and we've grown out of it because we're smart. And that is that vision involves a two-way process, that light comes in, changes happen in the brain, and the images are projected out to where they seem to be. Your image of me, I'm saying, is right here. It's not inside your head. It's in your mind, but it's not inside your brain. Everything you're seeing is in your mind, but it's not inside your brain. So we're projecting out images of this whole world. We're projecting out images of the sky and of stars. Our minds literally project out over astronomical distances. And this outward projection through what I call perceptual fields, which are a kind of morphic field, is an outward extension of our mind. Our minds reach out to touch what we're looking at. Sometimes we project out things that aren't there, then it's an illusion or a hallucination. And fortunately, those are rare, otherwise we would never have got here today. Normally, we project things out to where they are. This means that our minds, in a sense, reach out to touch what we're looking at. Now, is this just philosophy or poetry, or is it scientifically testable? Well, I think it's testable. And how I think it's testable is this. If I'm behind you, looking at you through a window, you can't hear anything, you can't see me, smell me, you don't know I'm there, and I stare at your back, could you feel me staring at you? Because my mind's reaching out to touch you. But as soon as you ask that, you realize this is a well-known experience. Surveys show that more than 90% of people have had the experience of feeling when they're being looked at from behind, they turn around and someone's looking at them. Or the vast majority of people have had the opposite experience. You look at somebody and they turn around. There is a slight sex difference. More women than men have experienced being stared at, and more men than women have experienced staring at others and making them turn around. But most people have experienced it both ways, and I'm sure most of you here know what I'm talking about. Now, this is a terribly well-known thing to adults and to children. It's known all over the world. It's been known throughout human history. So what does modern science have to tell us about it? Until recently, nothing. It was a completely taboo subject till the 1980s. You couldn't do research on it because it's impossible. The mind can't possibly influence other people by looking at them. Therefore, all this evidence is just anecdotal. The fact that millions of people believe it, and children believe it, and primitive people in uneducated parts of the world believe it, just proves you can dismiss the whole thing. And smart people don't believe it. University professors at leading universities deny that it happens. So it doesn't happen. It's impossible. People imagine it happens because it's a coincidence. You turn around, someone's looking at you, you forget the millions of times you turn around and no one's looking at you. That's the standard argument. But there were no data, no studies, nobody had ever measured how often people turn around when they're not being looked at. It was simply an armchair argument. But you can actually test this scientifically. We can move on beyond empty hypotheses, evidence-free, skeptical hypotheses. The simplest tests involve blindfolds. One person's blindfolded, another person sits behind them, and either looks at the back of their neck or doesn't look in a randomized series of trials. And each trial they have to guess if they're being looked at or not. These trials are so simple a child can do them, and millions of trials have, well, hundreds of thousands of trials have already been done, and thousands of children have done them. This was done in Britain, in Germany, and throughout the school system in Connecticut several years ago, with results that are overwhelmingly positive and significant. This experiment's been running in the Amsterdam Science Museum for the last 15 years, one of the largest experiments ever conducted in human psychology, with results that are overwhelmingly significant. This effect is real. That's no surprise to most people because they've observed it. It's a big surprise to the science that says it can't happen. And still most scientists deny that it happens because it doesn't fit the materialist theory. It can't happen. The evidence must be flawed. Even though no one's shown how it's flawed, it must be flawed. This happens with animals too. Animals can feel people looking at them. People can feel animals looking at them. I think that this is something that goes way back in evolution. I think it probably goes back to predator-prey relations when the eye first evolved 350 million years ago in the Cambrian. Any prey animal that could tell when a hidden predator was watching it would tend to escape better than one that couldn't tell. There'd be very good evolutionary reasons for this to evolve. We have it as humans not because we're special, but because we're animals. It's a basic ability that animals have. It's extremely widespread. The most sensitive people in these Amsterdam tests were children under the age of 10. And I think most of us get hardened to this. We live in the modern world, lots of people see us, we're in crowded cities, but children are more sensitive, but even most adults still are. So I think our minds are extended far beyond our brains through every act of attention and through every act of intention. Intention and attention involve the mind stretching out. We direct where our minds go. And the Latin words, the roots of our English words tell us that. Ad tendere is the root of attention. Ad means towards, tendere means to stretch, as intention, tend, etc. Intention means to stretch into, attention means to stretch towards. Our minds stretch out. I'll end up with just one final example of intention and how it can be measured. When we have bonds with other people, we belong to a social group with a kind of morphic field that links the members together. Flocks of birds, schools of fish are examples, packs of wolves. And human families, groups of friends. Whenever we're bonded with others, we have, I think, a field that connects us. And that field can connect us even at a distance. And I think that's the basis of telepathy. I've done a lot of work on telepathy in animals, as summarized in my book, Dogs That Know When Their Owners Are Coming Home, which is about dogs that know when their owners are coming home. I've done lots of experiments that show that a lot of dogs really do know when they're coming home telepathically. I have people come home at random times, in taxis or other unfamiliar vehicles. No one at home knows when they're coming. We film the dog the whole time they're out. And it's an objectively observable fact. These dogs seem to respond to their intention to come home. Now, in the human realm, telepathy is also quite common. And the commonest of all in the modern world is telepathy in connection with telephone calls. The great majority of people have had the experience of thinking of someone who then calls, and they say, "That's funny, I was just thinking about you." Or else, when the phone rings, before they look at the ID call system or before they pick it up, they just know who it is. How many people here have had that kind of experience? Well, that's the great majority. That proves you're normal people. And the great majority have had this experience. Now, what does science have to tell us about it? Well, for 100 years, since the invention of the telephone, nothing. The standard scientific argument was one you all have heard, you might even have said it yourselves. You sit back in your chair looking sort of sage and thoughtful, and you say, well, yes, you may appear to have had this experience. How do you know it's not just a coincidence? You think about people all the time, one of them rings, and then you might think it's telepathy, but you just forget millions of times you're wrong. Then you sort of sit back looking as if you've made a really smart point. And everyone's made to feel rather silly that they thought it might have been telepathy, because that's not meant to happen, and smart people are not meant to believe in it. Well, there's nothing wrong with the hypothesis. It's a reasonable hypothesis. But in science, you need more than a hypothesis. You need evidence. And if you ask these people, where's your evidence? They don't have a shred of evidence. It's pure armchair speculation. I've devised an experiment to test the skeptical chance coincidence theory, which I've now done many times, and it's been replicated, published in peer-reviewed journals and so on. And it's this. If this happens to you quite often, what we do is we set up an experiment. You sit at home, you're filmed on a video recorder continuously. You give us the names of 4 friends or family members you might be telepathic with, and their phone numbers. We then pick one of them at random by the throw of a die, or by a random number generator, and ring them up and ask them to call you. You know you're going to get a call from one of these 4 people, but you don't know which one, and you can't guess by knowing their habits of life, because it's picked by us at random. So the phone rings. Before you pick it up, you have to say to the camera who you think it is. I think it's John. You pick it up. Hi, John. You're right or you're wrong. By chance, you'd be right 25% of the time, 1 in 4. In these experiments, hundreds of them, people are right on average 45% of the time. The probability value of this is 1 times 10 to the minus 12. That's a statistical way of saying it's extremely probable there's something really going on. In fact, it's more probable than the existence of the Higgs boson. This evidence is now being replicated at the universities of Amsterdam and Freiburg. There's a filmed version of this experiment on YouTube. You can get to it from my website. It's called the Nolan Sisters Telephone Telepathy Test. It was done with the 1980s girl band, the Nolan Sisters. And you can do it yourself. I've just launched an automated telephone telepathy test online. You go to my website, www.sheldrake.org, go to the online experiments portal, you'll see the mobile telephone telepathy test. What you do is you register, put in your mobile phone number, and the cell phone numbers of 2 of your friends or family members. The computer then picks one of those 2 people at random, sends them a text message asking them to call you at a landline number, which is the computer. So they call you, and the computer puts them on hold. The computer rings you. Your caller ID says telephone telepathy test. When you answer it, it says, this is the telephone telepathy test. One of your 2 callers is on the line right now. Press 1 for Ashok, press 2 for Rupert. You make your guess, the line opens up, and you see if you're right or wrong, and you then talk to the person for up to a minute. It then cuts off because I'm paying for the call. In this test, on average, you'd be right 50% of the time. People are on average right about 60%. This is with unselected participants. It's a great basis for a student project, and it's fun to do, takes less than an hour. And I think the reason these phenomena happen is that when you want to call someone on the phone, you have an intention to call them before you make the call. Your intention reaches out to touch them across space, even if they're thousands of miles away. We've done tests between Britain and Australia, the Antipodes. It works perfectly well to people the other side of the world. What matters is not physical proximity, but emotional closeness. Well, that gives you a flavour of some of the questions that can open up the new research that's possible when you break the taboos, when you get beyond these dogmas. All this kind of research on telepathy, the sense of being stared at, is utterly taboo from the point of view of regular science. The frontiers of science are patrolled by organised groups of so-called skeptics, sort of vigilantes policing the frontiers of science. And they want to stop this research and stop people. They've managed to stop any government grants for this kind of research, and most universities won't tolerate it because it would undermine their credibility. The fact is these things happen, and most people know they happen, and the only reason that the research doesn't happen more widely is simply because of these taboos. So in summary, I think that in every way, when we question these dogmas of science, science becomes freer, it becomes more interesting and more fun. And what's more, it even costs less than regular science. And I think we stand on the threshold of a paradigm shift, a breakthrough, when things can open up and science can once again become more life-affirming and much more fun. Thank you.
Thank you.